examples. I want to multiply. And here's the deal. Yes, ma'am?
Is the quiz tomorrow?
No.
That's what I'm thinking.
I changed that out. I don't know. I don't know. I think it would just be done with this unit. We just take it. It's so fast. Yeah, I think it's just be fast. What I want to do, whenever you guys see these problems, don't write this down yet. I want to explain something to you. Because since you're going to have to multiply these things together or divide them or whatnot, in order to do that, they have to be in factored form. So don't write down the problem, factor it as you're writing it down. So if I'm looking at that first numerator, I have 4x minus 4x squared. What do I factor out of that? 4x. So as I'm writing these problems down, I'm factoring as I'm going. And I get that. I factor the denominator. What times what's negative 3 add together to get 2? X minus 1, x plus 3. Hey, before I go any further, these are very similar, aren't they? They're not the same though. What would I have to factor out of them, 1 minus x, to make it an x minus 1? If I take a negative 1 out of that, I get x minus 1. Be okay with that?
No.
Yes, you can. Yeah, you took out a negative 4. And sometimes you'll see these little things eventually at some point in time. Just remember the trick of factoring out a negative 1. If you factor out a negative 1, you can change. It changes the order in which you can write it, because then it becomes negative 1 plus x, which is x minus 1. Apparently, I deleted it. Okay.
Press the forward button.
So now, if that's a negative 1, I'm just going to rewrite this. I'm just working ahead a little bit. What times what's negative 6 you add together to get 1? 3 and negative 2. And now, since everything's written in terms, I can simplify out all the pairs of 1. When I simplify out the pairs of 1, I get an x minus 1 to go away. An x minus 1. A 4x. X plus 3, and I'm left with negative 1 times x minus 2. And I'm done.
Is that what this unit is?
What's that?
Is that like basically
Yep.
the unit?
That's all we're doing. Simplify, simplify, simplify. Yes, ma'am?
Do you want us to distribute?
No. And I'm gonna get to that here in a second. You don't have, when things are written out in terms, don't worry about distributing. You don't have to, because you can get 3 terms. There's no reason to write out a quadrant or cubic. No reason at all. There will be a time, and I have an example here in a second, when I would like you to multiply something together, and it's very obvious. It's when you have monomials. It's no big deal. Okay. Just leave it as negative 1 times the quantity, and you're fine. If you multiply it through, is it the end of the world?
Yes.
No, it's not. It's just you're just wasting time. Overachievers.
Not
All right. Oh no, I have to remember how to factor a difference of cubes or sums of cubes. Oh no. Let's see. A cubed minus b cubed is a minus b. Someone said x and wrote it down. A squared plus ab plus b squared. And what's different when it's a sum of cubes? First is the same, yeah. Yep. Okay. So in this case here, the 8x cubed, that's what's playing the role of a, is 2x. So we wind up with x plus 3 over 2x minus 1. What is the quantity 2x squared? 4x squared. So we have a 4x squared plus 2x plus 1 times, hey, look at that. Oh, man, goodbye. And you're done. X plus 3 over 2x minus 1. That's it. Sometimes life smiles on you.
No, we bring out the song in the
It
middle.
happens like that too. So far, so good? Alright. Oh no! I'm afraid. What do I do when I'm dividing?
Don't you have the same change left?
Same change, flip. Just flip it.
We just have the same thing.
Yeah. So we start off the problem the exact same way. 5x. Is there a GCF? No. So it's 5x. The denominator becomes what? Times, well, what times what is 8? We add together to get negative 6. Negative 4, negative 2, very good. And that goes over so the fun of simplifying. No, 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 no. You're done.
Okay, I really like this. This should be what we need the whole rest of the year.
It's not that this part is tough.
Yeah, that's easy.
It's not this part. It's going to be the application of it when we do this.
No, don't, I need to focus on what we're doing now.
I have. I've done like 2 problems.
I thought we were on 9.4.
We were. But you have to be able to do all that when you have all this. When you start solving for x. Okay. All right. Do this one. Please. It was 9 and 2, right?
Yeah.
So you group it. So what I'm doing here to save space-wise, I just factored that first part, did my couple of steps like I would normally, and I'm not rewriting the rest of it as I'm going. There's no reason to. So now I know that my numerator would be 3x minus 1, 2x minus 3, over 6x squared times 1 over, well, what comes out of here? X. And then, oh, this was supposed to be a plus, I'm sorry. Sorry about that. And that'd be a 2x plus 3. So the only thing that drops out here is the 2x plus 3. Did you guys see that I forgot, when I took out my negative 1, I forgot to make that plus? Sorry about that. I slept with the windows open. My head is killing me. Dude. Now, this is the example of where I would multiply something together. See how my denominator is 6x squared times x?
Then you just don't have to.
Yeah, what do you get then?
Like 7.
Yeah, you get 6x cubed. So you get 3x minus 1 over 6x cubed. And you're done. You cannot simplify anything else because the numerator is a binomial and the denominator is a monomial. There's no GCFs, there's nothing else to simplify out. You cannot simplify over addition. This is where most of you guys will make a mistake and try to cross off the 3x and a 6x cubed. You can't do that. That's unmappable.
Wait, couldn't you play war with X's?
No, because of the minus 1. You only play war if it's a monomial. Since it's got a binomial portion to it, the game of war is invalid. Is the game of war always invalid?
That's weird.
Dr. McKittrick, I'm understanding that your fucking bolts is up. Your computer's a big, I swear, I forgot how it goes. You ever see War Games?
No.
Yeah, Whopper. Dr. McKittrick, I'm under the impression your computer sucks. I think that's what it says. Yep. Would you like to play a game, Dr. Malvin? Yes, War Games.
I like the Matrix. What are we doing?
Oh no, so frightening when there's more than one to do. Oh. No, I don't. I'm trying to show you guys and build you up and not crush your dreams and aspirations on a Monday.
Oh, what the heck?
We haven't gotten to trig yet, so I haven't really crushed it.
No, where's the plant?
No, it's don't cry. Don't you remember this?
Jelly beans.
Today I'm like just
Remember the ratios of the sides?
Yeah.
And you're going to be fine. If you remember the ratios of sides, you're going to be fine.
I feel like sign over tangent, like your legs
Sine over tangent. Sine over tangent being cotangent. So, yes, that is cosine. Yes. That's trigonometric identities. And when we do that, you're going to love it.
Oh, yeah. You don't need to.
Yes, I does. Yes, I does.
You don't want to show
Oh, it's 14.
Oh, that looks just so fun. Or can make you feel
Make sure that equals that.
My dad told me that we're not letting me talk about math-wise in our house is
And honestly, it's just a puzzle.
Yeah.
And the trig properties are the key. If you understand the trig properties, it's just plug and play. And it's just, how do you get there? It's kind of like doing a proof without columns. This one, there's it's a lot of direct substitution. So in this one here, what is the 3x minus 5 over? Guys, it's over 1. A lot of times what they'll do is they'll take this one and they'll make that division, so you have to remember to flip it around when you multiply. So just be careful. This one is going to be pretty quick because 9x squared minus 25, that's a difference of squares. So you get 3x minus 5 and 3x plus 5. So now it's just a matter of what simplifies. Oh, it's divided. Yeah, I'm looking. So that's going to go here. It does that. So, boom, 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 boom. So we have x over 3x plus 5. And again, I cannot break that apart. I cannot break any of that apart. That is my final answer.
I need a smart board.
What's that?
I need a smart board in my house, just so I don't have to like.
Yeah, it's much nicer today.
Yeah.
All right. I think I have you guys. This is 94 OB. Didn't I already posted on the calendar?
Yeah, I know what those are too.
I'm gonna look up how much it costs to buy a smartboard.
Huh?
You know how cool it'd be to have a smartboard in your house?
Yeah. Well,
I think there's a way to do it where you just use a Wii controller and a whiteboard.
oh yeah, my dad is that was on Friday. They like just overhauled their library, and so they were like, yeah, we have like whiteboard walls, and I was like, yeah, I know what those are. They have those. Oh, we have smart boards. I'm like, yeah, I know what those are too. Like,
Who's that?
the guy who was giving me the college board.
Oh.
Model
Where'd you go to?
Bradley. So like just modeled all their like
That's cool.
the library, and I was like, they're like talking about all this stuff. I'm like, yeah, I've like had these since I was
Look
like
how
in third grade.
$5,000.